In this lesson, we'll look at reviewing expansion processes, and we'll do a little bit of a lead into binomial patterns. So that's going to be our focus, but I wanted to recover some of the vital skills that we'll need to be able to examine and work with binomial patterns properly. So the lesson for review today is basically reviewing expansion using area as an example. We'll review distributive law, and then we'll just look at expanding brackets and obviously multiple sets of brackets. So it should be a nice, easy review lesson, one where you go, yep, I've got most of these skills. And hopefully for those that are a little bit worried about this process, it gives you a chance to practice those skills. Okay, so if we start by looking at expansion using area. The idea with expansion using area is to simply break up a scenario into a manageable and visual form. So let's say I'm looking at x plus 2 multiplied by x. So a really simple scenario there. It's an expansion we probably already know quite well. The idea is if we set this up as an area, then we can say this side here is x. So it has a length of x. And the x plus 2 can be broken into two parts, actually. We can say that it's x, and we've also got a 2 there. So we don't use the x plus 2. We split it up, and we go, well, x and 2 can be broken into two compartments. Now, as soon as we do this, we can see that we're dealing with two areas. We've got an area which is x times x, and that will just be x squared. And we've got an area which is x times 2, so x times 2, and that will be 2x. So this form of expansion does make it a little bit easier to break it up into its components. So this will mean that my total area, or that expansion, will end up being x squared plus 2x. And of course, when we use distributive law, we're doing the same thing. We're going x times x and the x times 2, and we're keeping whatever that operation is in the middle. So one more example with this. We're not going to stick on this for very long. If we look at something like x plus 1 multiplied by 2x plus 3, the same thing can be done. So if we look at setting up an area where we can break each of those brackets up, we've got x and 1 here, so x plus 1, and we've got 2x and 3 here, so that'll be our 2x and 3. Don't stress too much about my spacing here. It's not to scale, it's just basically allowing us to break up those areas. So if we look at x times 2x, that gives us 2x squared. X times 3, we get 3x. 1 times 2x, we get 2x. And then we've got 1 times 3, which gives us 3. So you can see that this has allowed us to look at each of those expansions. X by 2x, x by 3, 1 by 2x, 1 by 3. And it's done the same thing as our normal distributive law, but a much easier visual representation. So we've got our 2x squared, we've got 3x, and 2x, and 3. And when we simplify that, these two are like terms. So we end up with 2x squared plus 5x plus 3. Now the reality is you probably won't use this very often, but it's nice to go back and look at that as an underlying feature behind that distributive law, what we're actually doing. We're looking at finding each of those areas and regrouping them back together to go, okay, this is our combined area. Okay, distributive law. So distributive law, it applies when we're looking at a single product. Now, distributive law basically says that each value in the first bracket will be multiplied by each value in the second bracket. If we went back a couple of years, communication was a component of mathematics that we graded separately to the actual mathematical skills, then it became more important for you to show more steps. Luckily, we're in a system now where we can kind of shortcut. But the idea is, if I looked at something like A multiplied by B plus C, distributive law is nice and easy. It's just going, well, A must be multiplied by each of those separately. So that would be A multiplied by B and A multiplied by C. And if we broke that into a scenario where we had two brackets, A plus B multiplied by C plus D, then what it's really saying is that A itself must be multiplied by the second bracket, and B itself must be multiplied by the second bracket. So we normally step this out a lot quicker, but the idea is that we're saying that A is multiplied by C plus D, and also B is multiplied by C plus D. So now by expanding a second time, we end up with AC and AD and BC and BD. Now, in truth, we shortcut this all the time. So we look at this A plus B, C plus D, and we use these shortcuts like FOIL or crab claw or so on, but the idea is the same. A will go to both values in the second bracket, and B will go to both values in the second bracket. So we can jump it straight to that AC, AD, BC, and BD, because that's each of those pairs, those product pairs that we're talking about. Now, the only extra is that FOIL and crab claw and whatnot, they only really apply if we've got two brackets, only two terms within each bracket. So as soon as we change this to A plus B plus C multiplied by D plus E, it all starts to fall down. If we use distributive law, or at least we consider distributive law, and we say, well, A must be multiplied by the second bracket, B must be multiplied by the second bracket, and C must be multiplied by the second bracket, then it starts to work a little bit cleaner, and we can say, well, that's just A multiplied by D plus E, and that's B multiplied by D plus E, and C multiplied by D plus E. So AD and AE and BD and BE, CD and CE. What I would prefer to do would be to look at A plus B plus C multiplied by D plus E and recognize that that just means that A goes to, or A is multiplied by each of those values in the second bracket, B is multiplied by each of those values in the second bracket, and C is multiplied by each of those values in the second bracket, and we end up with those same products. Now, I'm relatively confident with that skill that most of you can do that pretty fluently. Where it all starts to fall down is when we do something like this. So let's say that I've got three brackets now. I've got A plus B, C plus D, and E plus F. Now, really the idea in this type of scenario should be going back to what we did right back at the start when we looked at more than two multiplications in a row. And if I thought about 2 times 3 times 4, then what would we do? Now the answer is we do one multiply first and we get our answer. So we go, that's 2 times 3 and this is 6. And then we do our 6 times 4. So we only deal with a single product at a time, and we follow that order of operations. So we do this product, and then we do the next product, and we end up with 24. So don't fall into that trap of going, well, I have to multiply 2 by 3 and 2 by 4, and then I can join it up. It doesn't work that way. It's complete a full product, and then use that answer to that full product to multiply on to the next one. So in this scenario, I'm going to say that we'll do this product first, and we'll leave our A plus B in front. So if we've got A plus B, we look at our expansion. So we go C times E, and then C times F, D times E, and D times F. So this is CE plus CF, and DE and DF. Now, once we've done that, it's a matter of expanding these next two brackets. And maybe it's that distributive law is easier. So we go A multiplied by that whole bracket and B multiplied by that whole bracket. So A multiplied by CE plus CF plus DE plus DF, and B multiplied by CE plus CF plus DE plus DF, and we end up with ACE, ACF, ADE, ADF, and BCE, BCF, BDE, and BDF. Okay, so hopefully that makes sense. And now what we're going to do is we'll go through a couple of examples, and hopefully we can send you off to work through a couple of expansion problems, and then we'll look at our final focus at the end. So example 1, we'll look at 2a and b. Look at a nice easy one first. X multiplied by 2x plus 3 plus 2x multiplied by x take 2. And then we'll look at 2x plus 3 multiplied by x take 5. Okay, so example 1, nice and easy, focusing on simple distributive law. So here we've got 2x squared plus 3x, and then 2x squared, because that's a negative, it's subtract 4x. So 2x squared and 2x squared makes 4x squared, and we've got 3x, take 4x, that ends up with negative x. Second one, we're just using our FOIL or crab claw, or basically multiplying everything in the first bracket by everything in the second bracket. And we get 2x squared, take 10x, so make sure you take into account that 2x by negative 5, plus 3x, and then 3 by negative 5 is negative 15. So we've got 2x squared, these two are like terms, so we end up with negative 7x, take 15. Okay, example 2, we'll look at a little bit more complex. So for A, we've got 2x multiplied by x plus 2 multiplied by x take 1. And for part B, we'll look at 2x plus 5 take x squared multiplied by x cubed plus 2x. Okay, so the first one is a scenario where we've got two expansions that have to happen. I'm going to do this first. So I'm going to leave my 2x in front, and I'm going to expand out my binomial. So we've got x squared, we've got take away x, we've got plus 2x, and we've got take 2. So now we've got 2x, and we'll simplify the bracket because these are like terms, right? So we've got x squared plus x take 2. Now that we've done that part, we can expand the second bracket. So we can use that distributive law to multiply 2x by each of those three terms. So it gives us 2x cubed plus 2x squared and take 4x. So that's as simple as it goes. With our second one, we're going to use distributive law, and we're going to say that this 2x goes to the whole second bracket, as does the 5, and the negative x squared also is multiplied by that whole second bracket. So we get 2x multiplied by x cubed plus 2x plus 5 multiplied by x cubed plus 2x, and subtract x squared multiplied by x cubed plus 2x. So we've got 2x to the power of 4. We've got 4x squared. We've got 5x cubed and 10x. And then because there's a negative in front here, this is a negative x to the power of 5. And negative 2x to the power of 3. So the only like terms that I can see are the cubes. So 5x cubed and take 2x cubed. So we end up with 2x to the power of 4. We'll put them in descending order, so highest powers first. The x cubes give us 3x cubed because we've got 5 take 2. And if I was smart, I would have recognized that there's a negative x to the power of 5 there. So negative x to the power of 5 plus 2x to the power of 4 plus 3x cubed plus 4x squared, and then we're just left with plus 10x. Okay, so hopefully that makes sense. Definitely something to practice. Our last two examples, we're going to look at A, 2x plus 3 squared, and then B, x plus 3 squared take away x take 2 squared. So I'm hoping that you can remember the pattern, but we're not going to use the pattern today. So remembering that when we've got a bracket raised to a power, what it means is that we're multiplying the bracket by itself. So I'm going to get you expanded out the long way today. If you know your pattern, then you can take the shortcut. That's up to you. So we've got 2x plus 3 multiplied by 2x plus 3. And when we expand that out, we've got our 4 multiplications. So we've got 4x squared plus 6x plus 6x plus 3 times 3, which is 9. These guys are like terms, and we end up with 4x squared plus 12x plus 9. With our second one, we've got a difference. So we've got one expansion, x plus 3x plus 3, and we've got a separate expansion, x take 2, x take 2, that we have to subtract from that total. So our first one, when we expand it out, we've got x squared and 3x and 3x and 9. And our second one, make sure we keep this one in the brackets. We've got our x squared, take 2x, take 2x plus 4. So we end up with x squared plus 6x plus 9. Subtract x squared, take 4x plus 4. And then in that last step, now we can subtract. We've got x squared take away x squared, so that's gone. We've got 6x take away negative 4. And take away negative makes it positive. So we've got 6x plus 4x, which is 10x. And now we've got 9 take away 4, which gives us plus 5. Okay, so hopefully that makes sense. Now our last example, we'll just do one. We're going to look at x plus 2 cubed. Now the reality here is that that cubed means we're multiplying x plus 2 by itself 3 times. And as we discussed before, that means that what we want to do is we want to multiply 2 of them first, and then when we get that answer, we can multiply it by the third. So x plus 2. When we expand out this pair, we get x squared plus 2x plus 2x plus 4. So we've got x plus 2 and x squared plus 4x plus 4. And now when we look at multiplying by x and multiplying by 2, or we can do the same thing using distributive law, we get x cubed plus 4x squared plus 4x plus 2x squared, 8x, and 8. So grouping like terms, cubes, that's nice and easy. It's just one of them. The squares, there's 2, so we've got 4 plus 2, which is 6. The x's, we've got 4 plus 8, which is 12. And then we just got 8. Okay, so really that's our lesson today. That skill should be one that you know and that you've practiced a bit, and hopefully it's a really easy lesson for you today, and it's just fluency practice. What I want to point out, though, is that I've got 3 tasks. So the first one is math space expansion. If you don't want to work on math space, in the next tab, I've got a worksheet from math space that you can work through. Once you get through that, and once you've done enough practice, what I want you to do is I want you to show this. So I want you to show these patterns. I want you to look at x plus b squared and show that it is that pattern, a squared plus 2ab plus b squared. Look at a plus b cubed. Look at a plus b to the power of 4, a plus b to the power of 5. And see if you can do each of those expansions algebraically by hand to show these relationships. Now that expansion is good practice, but the real part of this is I want you to do a bit of an investigation. So I want you to examine the patterns. So can you see any patterns in the powers of A throughout these? Can you see any patterns in the powers of B? Can you see any patterns in the coefficients? So for example, 4, 6, 4. And can you see any pattern in the number of terms? So that's what I want you to do once you finish. That'll be a lead into the next lesson. Honestly, if you don't get there and you don't get to think about it, it's not the end of the world, because this will be what our next lesson is about. But for those people that are finding this really easy and want a bit of a challenge, then this is what I want you to do. Okay, thank you very much. And hopefully I'll see you in person next lesson.